Now, before we start using some algebra and some reasoning in order to figure out what the graphs of these absolute value functions look like, let's just graph some of them in Desmos and get a feel for an absolute value function here. So here's the graph of y equals x. I just made these original functions dashed lines to contrast them with the absolute value functions that we're about to graph. So the graph of y equals x, it has a x-intercept at 0, 0. It has a positive slope of 1. Now, an absolute value function, what that does is it takes the positive value of whatever x is. So if x is already positive, it leaves it the same. But if x is negative, it negates it to change it into a positive. So if we graph this on the same graph as y equals the absolute value function of x, you can see that where the graph of y equals x was already positive, so had a y value greater than 0, nothing changed. But where it had a y value that was less than 0, this gets reflected in the x-axis, and now this graph has a positive value of y instead of a negative value of y. So now I'm just going to take that original graph out, and we can see what the absolute value function of y equals x looks like. So just compare it to the original, and there's the absolute value function. Let's look at a slightly more complex linear graph. So we have y equals 2x plus 5. This one has an x-intercept at negative 2.50. So we see it is positive for values of x that are greater than or equal to negative 2.5, and it's negative for values of x that are less than 2.5. Well, we apply our absolute value function, and we can see that this portion, which is greater than or equal to negative 2.5, stays the same. But for the part that is less than negative 2.5, this gets reflected in the x-axis to become a positive y value. Last one, let's take a look at a quadratic now. So this is a quadratic. We have a vertex at 1, negative 4. We have two x-intercepts here. So one of them is negative 3, 0, and one of them is 5, 0. Just before I look at the absolute value, just try and picture in your head what this is going to look like for the absolute value function. So anything that's below the x-axis is going to be reflected. Here is our absolute value function for this graph, and I'm going to take the original off. So you can see that these two portions to the left and to the right of the x-intercepts stay the same. However, the portion that was below the x-axis has now been reflected. So what is really indicating the portions of the graph that get reflected is when we have these x-intercepts. So we have an x-intercept of negative 3, 0 here. We have an x-intercept of 5, 0 here. And the portion that's in between this gets reflected. Now, it could be that we have a graph like this. And in this case, when we reflect it with the absolute value function, it's not going to be the part in the middle that is reflected, but instead it's going to be the part to the left and to the right of the x-intercepts. So, as we can see here. So hopefully that gives you a little bit of a sense of what these original graphs and what the absolute value functions of these graphs look like. Now we're going to go in and start doing the algebraic calculations to graph these without the use of Desmos.